tend to view everything in the terms of kind of the inherent information content of the data that's being transported, right? So time series, for example. Time series samples have not much in the way of information value just in and of themselves, right? It's the analysis of the trends that are inherent in a collection of time series that really give you something to work with from an analytics perspective. The problem with that whole situation is that wherever you choose to do the compute part of this analysis of that time series data, you need to bring all that raw data stream to it, right? So if it's sitting in a cloud instance somewhere, you've got to take on the considerable effort needed to bring it from the source to its destination with fidelity. And if there's any time dependency associated with the transport of that time series, if you need to do analytics in near real time, it makes it even more involved. So in order to kind of work that out, that's really kind of an industry by industry, application by application type of problem. And you really need to optimize for the economic value that you're creating from the analytics that you are delivering. Yeah. So it's a match.
And having to work with the model, and again, back to the problem we're trying to solve to make the network more self-healing, unless I really transport that knowledge of the model through the network, through the potential points of failure in the network, I have no way of really addressing the specifics of what data loss might mean in a certain case.
Right.
So from a framework perspective, right, as we navigate these various layers here, what do you see as necessary improvements to the stack to represent the model, to capture the model, to pass it on from the world where the model is meaningful, to the systems where now we need to action certain things like remediation at a technical level, for instance?
I think there's a couple parts that we need to be careful about. One is we tend to depend a little too heavily on like one specific cloud. And so having data that can stream or move between different solutions, and there being some form of platform where application developers or data scientists can get at it no matter if they're in China or in the US, or if they have moved between Amazon or Azure. It's important that you create and build a framework that can manage and be robust enough to sit on top of all of those clouds. It's also important that as you scale your data, or scale against, like I'm sitting here looking at the stuff flash at me, as you add more and more washing machines or stoplights and add that data in, you're as an application developer, the framework that Pivotal has helped build is to connect and allow you as an application developer to scale your application to manage the data that you're consuming. And so you want to detach your dependency on raw infrastructure from the scale in which the data you want to consume is. So how can you move between clouds or pieces of infrastructure to consume whatever data you need? And then in terms of self-healing, by maintaining a platform agnostic or cloud independent approach, you end up healing yourself by saying we can distribute our load all over the world based on cost or demand, essentially commoditizing what would be the servers that we all buy.
Mm-hmm. So redundancy at various levels,
yes.
That you would say. I'd like to connect
Yes.
this.
So essentially adding to Austin's point that you need to have the network or the applications need to have enough intelligence to understand what these devices are, not to bank too much on the devices themselves to be more intelligent. So there are two paradigms of the network model or the compute model, right? Where you have network intelligent or device intelligent. Here we are going into a really new realm where we have both sides being intelligent enough. But despite that, the network is a property of the network and not of the devices themselves. Mm-hmm. So when we start thinking about how we are going to achieve the next level of self-healing networks, self-healing data management routes, we need to start thinking about how we are going to route data, how we are going to achieve priority-based routing, how we are going to achieve destination routing based on certain metadata that are attached to the data itself, not bound by who is sending or who is getting it, but rather what the data itself is inherently is. So essentially, the path to that is to make the network intelligent, not make it dumb, as we've been doing the past couple of decades now.